lesson 1.4, measuring angles. So the goal for this lesson is to compare and find the measure of angles. So an angle is formed by two rays with the same endpoint. So you see over here, you have a ray here, and you have a ray here, and an endpoint at A. The rays are the size of the angle, and the endpoint is called the vertex of the angle. So there are three ways to name an angle. The first way is by its vertex. So this would be angle A. The second way is a point on each ray and the vertex. So angle BAC or angle CAB. Doesn't matter what direction you're going. And the third way is by the number. So that is angle 1. So we're going to try an example. Name the following angles using the diagram below. So we have angle 1. So let's say the way we name it is angle JMK, or we could use the same thing, but KMJ. The one thing that you might be thinking is, well, why can't I name it angle M? Because isn't that the third way of doing it? Naming it by its vertex? But for this angle, that doesn't necessarily work, and I'll explain it to you why. B, what are the two other names for KML? So if you see KML is this angle. This one. So the other way to name it is LMK, or you could say angle 2, because you can use a number to label it. So I said I would come back to this. Would it be correct to name any of the angles angle M? So let me just erase this up. So think about it. If I was saying angle M, is this angle M? Is this angle M? Or is this angle M? We do not know. There is no clear angle to label angle M. So when they're connected angles and an angle is not individual, we cannot use its vertex. So in this case, we're saying no, because it is not clear which of the three angles would be angle M. One way to measure the size of an angle is in degrees. To indicate the measure of an angle, we write measure, so that's measure of angle A, and then whatever it is. We use protractors to measure an angle. So the next postulate is called the protractor postulate. So consider a ray OB and point A, and it's asking you to find the degree. So every ray formed by OA can be paired 1-to-1 with real numbers 0 to 180, and it goes 0 to 180 this way as well. Just like the ruler postulate, the protractor postulate lets you calculate angle measure using the absolute value of the difference. So you can subtract the two numbers and find the absolute value of it. So this is a review. You should have done this in middle school plenty of times. So we have acute angle from 0 to 90, right angle 90, obtuse more than 90 but less than 180, and straight angle is equal to 180. So that's like a line. So describe each angle as acute, right, obtuse, or straight. So you have angle A, B, C. So how much is angle ABC? If you see, you can see that it is 70 degrees. So it's between 0 and 90. So it is going to be an acute angle. Then you have CBD. So if you remember from the notes, a straight angle, a straight line is 180, right? So let's not even get into it. Just look at the image. Does this look to you more than 90? But is it more than 180? 180 is a straight line, so it's less than a straight line, but it's more than a right angle. So I'm just going to say this is between 90 and 180. So that's going to be an obtuse angle. Next one is CFG. So CFG. That's a 90-degree angle, so it is a right angle. You might be learning this later, but if you see that a straight line is 180, so if this half is going to be 90, that part's also going to be 90 to form 180. And the last one is CFH. So if you see that, that's the straight line. So it's a straight angle because it's a straight line. Okay, so now we're going to go to the protractor postulate, and we're going to try to figure out how much each of the degrees are. So you have L, K, H. So let's start with L and go with H. I'm going to use the outer numbers. You could use the inner numbers. You'll get the same answer. So I get 35, absolute value of 35, minus H is 0. So that gives me 35 degrees. And you have to classify it, so that is an acute. Next one is H, K, N. So that is, if you see it, it's 180 minus 0, which is 180, and that's going to give me a straight angle. The last one we're going to do for this one is M, K, H. So let's go from H this time. So it's 0 minus 145. Again, it is the absolute value of it. So it's absolute value of negative 145, which is going to be 145. And that is going to give me an obtuse angle. Sorry about that. All right. We're going to continue. L. I'm going to go faster on this one. L, K, N. So that is 180 minus 35, which gives me 145. And that is obtuse. Then I have J, K, L. That is 35 minus 90. absolute value of that. So that is 55. So that's going to give me an acute angle. And the last one is J, K, N. So if I see the outer numbers, it's 180 minus 90, which is going to give me 90. And that is a right angle. All right. Angles with the same measures are congruent angles. So we did the congruent segments, same thing with congruent angles. If you have the same measurements, it's going to be congruent. So if it's equal, it's congruent. If it's congruent, the measure is going to be equal. Use the diagram below. Which angle is congruent to WBM? So let's go to WBM. So W, where is B? So this is WBM. So if you look at it, it has only one arc here. So what other angle has one arc? I see one here. So I'm going to label that angle AED is congruent as they both have one arc. Okay, so like segment addition postulate, we have angle addition postulate, where if you see this angle plus this angle gives you the big angle. So part plus part equals whole. So let's try this example. So you have DEC, which is that, and CEF, which is that. So it's asking us to find each individual angle. So how much does it equal? Well, together they equal 180 because it's a straight line. A straight line equals 180. So I'm going to add them up. I'm going to say 11x minus 12 plus 2x plus 10 equals 180. So that gives me 13x minus 2 equals 180. I get 13x equals 182. I'm going to divide my 13. I get x equals 14. So I get x equals 14, but now I have to plug it in. So 11 times 14 minus 12 gives me 142. And then 2 times 14, that's 28, plus 10 gives me 38. And a good check is, do they add up to 180? Well, yeah, 142 plus 38 gives me 180. So that is my check. Same thing over here. It tells you ROT, so the big angle is 155. So let's try this again. So we add them up. So I get 4x minus 20 plus 3x plus 14 gives you 155, which gives me 7x minus 6 equals 155. So that means 7x equals 161. When I divide by 7 on both sides, x is equal to 23. So again, I'm going to plug it in. ROS is 4 times 23 minus 20. And that gives me 92 minus 20, which is 72. And 3 times 23 plus 14, which is 69 plus 14 equals 83. And a good check is to see if they add up to 155, which they do. And that is the end of lesson for 14.4.